Hi everyone, welcome to today's lesson. We are going to start talking about transformations. You guys have already learned this before. We're just going to kind of do a quick review of this. We're going to remember how to do translations, reflections, and dilations. All right, so first off, we have to know what a transformation is. If you think of the movie Transformers, it means to take a robot and transform it into a car, or vice versa, a car to transform it into a robot. So all of the pieces change position or orientation of that figure. Okay, so for example, the pre-image is what we start with, and the new image is the after. And the new image, to show it on a graph, it's read as prime. So hence the name Optimus Prime comes from this. So for example, if I had the original point, a lot of times you'll hear me refer to it as the OG. Let's say that was A. If I did any kind of transformation to it, so if I turned it or flipped it or anything, I would call it the new A prime. That indicates that there was one transformation that took place. So maybe I rotated it. Well, if I did something else after that and got another new point, we'd call that a double prime. So however many little apostrophes there are there tells us how many transformations took place. And if you remember, there are actually 4 types of transformations that we're going to talk about. So translations, reflections, rotations, and dilations. I'm going to talk about rotations tomorrow. I am going to talk about the other 3 today. Rotations is a little bit tougher, so we're going to spend more time on that one. Now, all of these transformations affect the size or the position of the image, but never the shape. If something is a star, it's always going to be a star. If it's a rectangle, it's always going to be a rectangle. It might get bigger or smaller, and it might move, but it's never going to turn into a different shape. Okay, so let's talk about translations. This is the first one. If I had to say one word for a translation, it is a slide. So translations slide along a line. So for example, it could slide straight across, it could slide diagonal, it could slide up, it can slide all different directions. Okay, just like a chess game. Okay, so things you have to be careful about when you do these slides is that you have to move each point the same direction and the same number. So in this case, we translated it to the right, and I have to move it. It looks like 1, 2, 3, 4, 5, 6 places to the right to get to the new A, or again, A prime. Now, if I move that one 6 to the right, I need to move everyone 6 to the right. In the end, we should end up with 2 pictures that look exactly the same. So we call those congruent. So congruent figures are figures that have the same shape and the same size. It's like they're equal, but we never say shapes are equal. Instead, we use the word congruent. Again, that means same shape, same size. All right, so let's continue and try to do a few translations on our own. So this is the shape we want to translate. Remember, translate means to slide. We're going to slide this figure 3 units to the left and 5 down. So let's start with A. Count 1, 2, 3 left, and 1, 2, 3, 4, 5 down. And that's the new A, and if you remember, we call it A prime. And we're going to do the same thing with B. 3 left, 1, 2, 3, 4, 5 down. B prime. Now, some people can start filling in the shape because they know that these 2 shapes should be congruent. That's fine if you want to go that route, or if you want to count each letter individually, going 1, 2, 3 to the left and 1, 2, 3, 4, 5 down. Same with D, you can go 1, 2, 3 left and 5 down, or you can say, oh, I know what this shape's going to look like because it should be congruent, and I can kind of fill in that part. Either way, as long as you end up with the exact same shape. So 2 congruent shapes. That would be our new figure. Now in math, we don't always use words to describe what's happening. If we can, a lot of times we'll use letters and symbols and numbers. And so I could tell you to translate a figure by giving you this. We call this coordinate notation. And so in class, I just asked, how is this shape moving? And somebody did figure it out. They knew which way to move. So think about your x-axis. Your x-axis goes left and right. Now, if it's left, we go towards the negatives. If it's right, we go towards the positives. Since this is a positive 1, we're going right 1. Your y-axis goes up and down. If we go down, we're going towards the negatives. Up, we're going towards the positives. So since this is a y minus 5, we're going to go down 5. So we're going to go ahead and move this shape, right 1 and down 5. And we'll call all the new points, again, prime. So right 1, down 5, that'd be B prime. C, go right 1, down 1, or sorry, down 5, that'd be C prime. So this is our new shape. Notice same size, same shape, congruent. That's a good sign. If it's not congruent, we made a mistake. And we're going to say our new points. So A prime is -1, 0. B prime is 1, -5. And C prime is -3, -5. Now in class, I kind of showed this to help them make a connection. The original A was -2, 5. And when I followed the rules of right 1, down 5, I got the new A prime. But you could have also followed the rules with the coordinate notation. It says to take your x and add 1. That would give us -1. It says to take your y and subtract 5. That would have given us 0, which notice that is our A prime. So that's kind of where the connection comes into place. All right, so one last question, because you might be asked a question that looks a little bit differently, and you might be given the transformation and asked a few questions, and you have to say if they're true or false. So first off, when this happens, you need to identify which one's the original figure. The only way you can tell this is by looking for the prime. Prime means new. If there's no prime, that's the original, the OG. Okay, so this is going to be a little confusing to you at first. It's going to take some practice. This symbol you might not have ever seen before, but we've already talked about it today. That symbol is like equals, but we don't say shapes are equal. We say shapes are congruent. So that means congruent. Again, same size, same shape. Now this one, again, it is something new to you. It just says XY, and there's a little line above it. That doesn't mean repeating. That means the line segment. Okay, so that means that is the length between X and Y, or it's the actual line between X and Y. So is this line congruent, so same size, same shape, to X1, Y1? Are they the same size? Yes. Same shape? Yes, that is true. Okay, next question. It says, was our original translated down? Yes, it was actually translated down and right. Was it translated to the left? We just said it was down and right, so that one would be false. Okay, so we've covered the first type of transformation. We covered translations. Now we're going to move on to reflections. All right, so if I had one word for a reflection, it would be a flip. And we need something that we have to flip across. We will always have some kind of line that we're going to flip, or some kind of mirror where one should be on one side of the line and one should be on the other side of the line. And we call that line the line of reflection. And this will always be given in the problem. You won't have to worry about figuring that out. It will tell you. So when I flip shapes, let's see if I can find a, well, here we have a reflection. Are the two shapes congruent, similar, or neither? So first off, are they the same size? These two triangles are definitely the same size. Are they the same shape? Yeah, they're both triangles. They're both right triangles. So yeah, they're the same shape. Same size, same shape means congruent. Similar means same shape, but different sizes. That's the difference between congruent and similar. Congruent, everything's the same. Similar, same shape, but one's either bigger or smaller. Okay, so let's practice a reflection. Again, the main thing on this is to find the line of reflection. So one is the x-axis here and one is the y-axis, and that is the biggest mistake when doing these problems. Okay, so first off, I'm going to highlight so I don't forget the axis that I am reflecting across. So in this case, it's the x-axis. In this case over here, it's the y-axis. Also, there is a line missing that I'm going to draw in at -1, just so I don't get confused. Okay, so what this line of reflection is talking about is if I would fold it on that line, so fold your paper in half, where would the shape appear? And so some people will even fold it and they'll poke holes in the vertices and see where it shows up, and that will work. If you need to do that, feel free. So I visualize it is I have to have one shape on one side of the line and one shape on the other side of the line. So since I already have one above the line, I need to have one below the line. So I'm going up and down. So however many boxes I have to count up, I have to count down that many boxes. So G was 1 up, G prime is going to be 1 down. F was 4 up, so F prime is going to be 4 down. Same with H. H was 4 up, so H prime, stay on that up and down line, is going to be 4 down. And E was 7 up, it needs to go 7 down. In the end, I should have 2 congruent shapes. Same size, same shape. If you do, it's usually a good sign. All right, so now we're going to try to reflect across the y-axis. So again, I should fold it on that line, that up and down line here, and I should have a shape on either side. So since I already have one on the left, I need one on the right. So I'm going left and right this time. So however many left a letter is, I need to go that many right. So F is 2 left, I need to go 2 right to get F prime. G was 4 left, so I need to go 4 right to get G prime. H was 8 left, so I need to go 8 right. And E was 6 left, so I need to go 6 right. I'm going to connect my points. Again, I should have a congruent shape, meaning same size, same shape. All right, so now we've got reflection. I'm going to move on to the last one for today, which is dilations. And if I had to say one word for a dilation, I would use the word to resize. In other words, we're going to change the size of the shape. It could get bigger or it could get smaller. Either one can happen on a dilation. Notice the shapes did not change, so a star is still a star. In this case, it just shrunk. Okay, so we're going to have a few steps here. So step 1, we need to find the coordinates of the original figure. It's the only one you have to find those points first before doing anything else. Step 2 is to multiply all of those coordinates by the scale factor. Again, the scale factor will be given in the problem. And our third step is to now plot your new points. And I added this when dilation is centered around the origin. We will always dilate around the origin, at least in pre-algebra and geometry, you might not. I just didn't want you guys to get confused when you saw that wording. Okay, so let's apply these 3 steps to 2 more problems here. So I'm going to start off by naming each of these points. So A is the point -1, 3. B is the 0.10, and C is the -0.30. When I dilate by a scale factor, in this case we have a scale factor of 2, I need to multiply everything by that 2. So our new points would be -2, 6, 2, 0, and -6, 0. So let's see what this shape now looks like. So we're going to go left 2, up 6 for A prime, right 2 for B prime, and left 6 for C prime. And in this case, our shape got bigger. We called that an enlargement. So I asked the students how they thought I would get the shape to become smaller, and somebody came up with the fact that the scale factor should be a fraction, and that's true, a fraction less than 1. Okay, so we're going to try this one out. We're going to do a scale factor of 1/3. Again, follow your steps. So step 1 is to find the old points. So A is the 0.33, B is 6, 0, C is 3, -3, and D is 0, 0. And we are going to multiply everything by the scale factor of 1/3. And our new points should be 1, 1. 1/3 of 6 is 2, so 2, 0. And we have 1, -3, and 0, 0. So if I plot these points, I'm going to go right 1, up 1 for A prime, right 2 for B prime, C prime is right 1, down 1, and D prime is stays where it's at. So we would have a smaller diamond here, or smaller square. When it gets smaller, it's not called an enlargement, it's called a reduction. All right, I'm going to have you guys pause here and try this last problem on your own. So you are already given the transformation, you just have to answer some questions in the true false table. Okay, let's see how you guys did. So first off, you have to figure out which one's the original versus which one's the new. New is designated by prime. The original, or the OG, is the one without anything else. So this figure represents an enlargement. Did our original get bigger? That was false. Okay, so the next one was that the scale factor, or sorry, the figure was dilated by a scale factor of 1/2. So let's test a point. I'm going to test this point. That's the 0.80. And it went to C prime, which is 4, 0. Was it multiplied by 1/2? Yes, it was. Okay, this one stumped a lot of people in class. So this is not talking about the entire square. This is talking about the angle. That symbol stands for angle. So the angle on A, so I'm going to look at angle A, is actually a 90-degree angle. Is that, again, this symbol means congruent to angle A prime. A prime is also a right angle, or 90 degrees. Congruent means same size, same shape, and that is definitely true. They were both 90-degree angles. But the next question says, are the squares congruent? Again, congruent means same size, same shape. They are not the same size, so that's false. And last one, it says square ABCD was translated. Well, we have to know what translated means. That means it was slid down. Was the shape slid? Answer is no. It wasn't slid, it was dilated. All right, that's it for the lesson today. Hopefully this is helpful. If you have any questions, shoot me a message on Schoology. All right, see you guys.